On the very last day of a field expedition that had otherwise turned up nothing worth remembering, a researcher combing the Peruvian desert nearly walked past a skull broken into pieces and buried upside down in the sand. What that skull belonged to had no real precedent anywhere in the fossil record of whales. Every sperm whale alive today feeds by suction, hunting squid in total darkness thousands of feet down, without ever needing to bite anything larger than its own throat can swallow whole in one motion. The animal buried in that Peruvian sand hunted nothing like that at all. It had a mouth built to bite, teeth built to kill, and a body built to take down prey the size of an entire whale. Start with what modern sperm whales actually do, because the contrast is the entire reason this discovery mattered so much to researchers studying the family's history. The living sperm whale, Physeter macrocephalus, has teeth only in its lower jaw, and even those play essentially no functional role in how it actually feeds day to day. Diving thousands of feet into darkness, it hunts giant squid almost entirely by suction, drawing prey into its mouth rather than biting down on anything at all, an approach that works well for soft-bodied prey but leaves the animal with no real capacity to kill or dismember anything solid, armored, or large. For decades, that suction feeding strategy shaped how scientists pictured every member of the sperm whale family, living or extinct, treating powerful biting and active predation on large prey as something entirely outside what this particular branch of the whale family tree was ever built to accomplish. That assumption began unraveling in November of 2008 when a research team led by Belgian paleontologist Olivier Lambert was wrapping up an otherwise disappointing expedition through Peru's Pisco-Ica Desert, a region already well known among paleontologists for producing exceptional marine fossils thanks to its dry climate and exposed sedimentary layers. Lambert had organized several expeditions into the region, specifically hoping to find a complete skull belonging to this poorly understood group of giant fossil sperm whales, and each previous attempt had come up short despite the team's best efforts and considerable time invested in the search. On the final day of this particular trip, with the team preparing to leave empty-handed once again and already mentally packing up equipment for the long journey home, Dutch researcher Klaas Post spotted something unusual jutting out of the sand. An enormous cetacean skull found upside down and broken into pieces, roughly 3/4 complete, once the surrounding rock was carefully cleared away over the following hours of careful excavation work. Large skulls at this particular site typically belong to baleen whales, filter feeders with no teeth at all, but Post noticed something that immediately ruled that identification out entirely. This skull had enormous teeth, and not just in the lower jaw, the way a modern sperm whale would show, but in the upper jaw as well, a combination nobody studying this group of whales had expected to find on an animal this size. If you're finding this interesting, be sure to subscribe to understand more DNA from the past. The team spent nearly 2 years carefully preparing and studying the specimen before formally describing it in the journal Nature in 2010. They initially named it Livyatan melvillei, honoring both the biblical sea monster and Herman Melville, author of Moby Dick, a novel built entirely around the hunt for a different kind of formidable whale. They quickly discovered the name Leviathan had already been assigned decades earlier to an extinct mastodon, a genuinely unrelated animal from a completely different branch of the mammal family tree, creating a conflict that the strict rules of zoological naming simply don't permit under any circumstances. The animal was renamed Livyatan, the original Hebrew spelling of the same word, while keeping melvillei intact as the species name honoring Melville. The numbers behind the discovery made clear exactly why researchers were so struck by it in the first place, once the full analysis was complete. The skull alone measured roughly 3 meters, about 10 feet, long, an imposing size even before accounting for the rest of the animal's body. Individual teeth reached up to 36 centimeters, over 14 inches, with a diameter of up to 12 centimeters, making them among the largest predatory teeth ever documented in any animal that has ever lived on Earth, extinct or otherwise, rivaling or exceeding even the largest known Megalodon teeth in raw dimensions. Whale evolution specialists reviewing the find described it using blunt, direct language rarely seen in academic papers. The biggest tetrapod bite ever found, a mouth roughly 6 feet long and 4 feet wide, 3 times the width of a modern killer whale's mouth, and large enough to comfortably fit an adult human being inside it without much difficulty. Based on those proportions, researchers estimated the full animal reached somewhere between 13.5 and 17.5 meters, roughly 44 to 57 feet, comparable in overall length to a large modern male sperm whale, but built for an entirely different way of life and a completely different diet. What that skull actually revealed went well beyond simple size, extending into the specific mechanics of how the animal actually hunted and fed. Unlike the modern sperm whale's long, narrow snout, built purely to house the organ responsible for its distinctive echolocation clicks used for navigating and hunting in total darkness, Livyatan had a short, wide snout reinforced with robust jaw bones and an unusually large temporal fossa, the muscle attachment point behind the eye socket directly responsible for generating bite force in any predator. That combination told researchers this wasn't an animal built for suction feeding at all, and never had been. It was built to clamp down hard and hold on, resisting a struggling animal's attempts to break free, rather than simply drawing prey inward the way its modern relative does from a comfortable distance, a mechanical difference reflected clearly in nearly every measurable feature of the skull. Researchers examined during their analysis. Based on the size and structure of the jaws, researchers concluded Livyatan likely preyed on medium-sized baleen whales, roughly 7 to 10 meters or 23 to 33 feet long, along with seals, dolphins, sharks, sea turtles, and giant squid, an apex predator occupying a role that no toothed whale alive today, including the modern killer whale, comes anywhere close to filling at this scale or with this level of raw physical power. Some researchers have proposed the Livyatan likely hunted in coordinated pods of roughly 8 to 11 individuals, similar to the tight social structure seen in living sperm whales today, a cooperative strategy that would have let it take down prey too large or dangerous for any single animal to safely handle entirely on its own, spreading both the risk and the reward of hunting something that size across an entire group. Livyatan wasn't an isolated oddity within the whale family tree either. Paleontologists studying Miocene marine fossils had already recovered scattered, unusually large teeth from several other sites around the world in the years before Livyatan's skull was found, teeth clearly belonging to some kind of oversized, actively predatory sperm whale relative, but without any matching skull or jaw. Researchers had no way to connect those isolated teeth to a specific body plan, feeding style, or precise identity. Livyatan's discovery gave that broader category, now generally referred to as macroraptorial or raptorial sperm whales, its first genuinely complete anatomical picture, confirming that an entire group of giant, actively hunting whale relatives had once existed alongside the ancestors of the modern, suction-feeding sperm whale, occupying an ecological role that vanished from the oceans once this particular branch of the family eventually died out. Subscribe to not miss the next one. Livyatan wasn't hunting in an empty ocean either, and understanding its neighbors matters just as much as understanding the animal itself. The same Peruvian waters that produced its fossil remains, roughly 12 to 13 million years ago during the Middle Miocene, were also home to Megalodon, the giant shark already established through decades of separate research as one of the most formidable predators in the entire history of the planet. Two apex predators of comparable overall scale: one, a shark relying on raw bite force, speed, and an ambush-style attack; the other, a whale relying on intelligence, coordinated group hunting, and a bite specifically engineered to grip and hold rather than shear cleanly through flesh, appear to have shared the exact same waters and very likely competed directly for many of the same prey species during the same narrow window of geological time. Researchers studying the ecology of this period now treat the Middle Miocene coastline of Peru as one of the single most predator-dense marine environments ever documented anywhere in the fossil record, a period sometimes informally referred to among paleontologists as a golden age of marine apex predators, well before later shifts in ocean temperature, prey availability, and interspecies competition gradually reshaped which lineages ultimately survived long enough to reach the modern era intact. That same stretch of coastline has since produced fossil evidence of numerous other large marine species from the same general time period, painting a picture of an unusually rich, productive marine ecosystem capable of supporting multiple enormous predators simultaneously. A level of predator density that has no direct equivalent anywhere in today's oceans, where large apex predators tend to be spread far more thinly across vastly larger ranges. Livyatan's story didn't end with the original Peruvian skull either, and subsequent discoveries have only widened the scope of what that first find actually represented. Isolated teeth matching its distinctive size and shape have since turned up at fossil sites scattered much further afield, including Chile, Argentina, South Africa, Australia, and California, suggesting either that Livyatan itself or a very close relative built along the same macropredator body plan ranged far more widely across the ancient oceans than the original 2008 discovery alone could ever have shown on its own. One particularly striking tooth, recovered decades earlier from Pliocene rock layers at Beaumaris Bay in Australia, and only later recognized as a likely match once Livyatan had been formally described and its distinctive tooth shape documented in detail, dates to roughly 5 million years ago, several million years younger than the original Peruvian holotype specimen. That gap suggests this lineage of giant, actively hunting sperm whales may have persisted and continued spreading across the world's oceans in some form for millions of years longer than the single skull found in 2008 ever revealed on its own, quietly surviving in scattered populations long after the specific individual whose skull ended up buried in that Peruvian desert had died. Line up everything that skull, discovered upside down and broken on the last day of an otherwise empty expedition, actually revealed, and the picture of sperm whale evolution changes considerably from what researchers had assumed going into that final day in the field. Modern sperm whales, with their suction-feeding strategy and functionally toothless upper jaws, had made it easy to assume this entire branch of the whale family had always specialized in something closer to gentle, methodical foraging in the deep ocean, rather than active predation on large, dangerous, and well-defended prey. Livyatan proved that assumption was never true for the whole family, only for the specific branch that happened to survive long enough to reach the present day relatively unchanged. Millions of years before killer whales evolved their own, considerably smaller scale reputation for hunting other marine mammals along coastlines around the world, an animal roughly the size of a modern sperm whale was already doing exactly that on a far grander scale, built with a bite specifically engineered to take down prey as large as another whale, hunting in the same waters as Megalodon itself during a period when the ocean's largest predators genuinely had few rivals left anywhere to fear. The skull that almost got left behind in the sand, buried and broken after millions of years underground, turned out to be proof that the sperm whale family once produced something the ocean had never quite seen before it, and, based on how abruptly the fossil record for this particular lineage seems to cut off, may never fully see again in quite the same form.